Most teams pick the wrong SBOM format, and it's too late when they realize that it doesn't show security vulnerabilities. I'm going to show you how to choose the right one the first time. I'm Chad Butler. I built security programs at SAP, Amazon, and Disney, and I've seen this confusion come up more than once. So here's what you're going to walk away with. First, a clear breakdown of the 3 most popular SBOM formats. Second, the one critical difference that matters for most security teams. And third, a simple decision framework so you can pick the right format today. All right, so there's no tools required for this one. However, if you want to play around with SBOMs in GitHub, it'd be really helpful to sign up for a free GitHub personal account if you don't already have one. Okay, so let's jump in. There are 3 SBOM formats: SPDX, CycloneDX, and SWID. Here's why this matters. So each SBOM format has several strengths and weaknesses or gaps. If you pick the wrong format, you're going to miss out on critical data, or you'll waste weeks building something that doesn't meet compliance requirements. Let's make sure that doesn't happen. Let's start with SPDX. This is the most widely adopted format. It's led by the Linux Foundation, and most major Linux distributions use it today. It's defined by an ISO standard, and SPDX excels at one thing: license compliance. It'll tell you every component, every version, and every license in use. But here's the critical gap. SPDX does not include vulnerability information by default. Now, recently the project released version 3.0, which was a breaking change, and that release included a security profile. The security profile allows you to add vulnerability information, but you have to upgrade to version 3.0, and you have to enable the security profile to get that to work. So if you're using SBOMs primarily for security, SPDX isn't the top choice. Now let's talk CycloneDX. This one was built by OWASP specifically for security use cases. Now, CycloneDX includes everything SPDX has: component names, versions, licenses, all of that stuff. But it adds a security layer as well. You get vulnerability data, cryptographic hashes, and full dependency trees. This format is designed for teams that need to find and fix vulnerabilities fast. And the tooling support is pretty great. GitHub, OWASP Dependency Track, and most modern scanners support CycloneDX. So if security is your primary driver, this is your format. Finally, there's SWID. SWID comes from an ISO standard for IT management that was first published way back in 2006. It's used primarily for enterprise software identification. This standard introduced software identification tagging, and it helps IT teams track software and versions in a normalized format. You'll probably see SWID in federal procurement and large regulated environments. But here's the thing: open source maintainers don't really use it, and like SPDX, it doesn't really focus on security vulnerabilities. So SWID is good to know about for compliance conversations, but for day-to-day security work, it's not really our best choice. Now here's the mistake I see all the time. Teams use GitHub's built-in feature to export an SBOM. They think they're getting vulnerability data because they just saw it in the dependency graph. But GitHub's native export format is SPDX. So all that vulnerability intelligence you saw in the web UI isn't in the generated SBOM file. Make sure you understand what format you're actually getting. Okay, so you understand the 3 major formats. Now let's make this practical. How do you actually decide which one to use? It may seem obvious at this point, but let me give you a simple framework that consists of 3 questions to ask yourself. First question: what's your primary goal? If your answer is license compliance, go with SPDX. That's its strength. If your answer is security vulnerability management, on the other hand, go with CycloneDX. Second question: what tooling are you using? Now, if you're using any of the excellent OWASP supply chain tools, or you want to integrate with your CI/CD pipelines, CycloneDX has excellent native support. So you may find some tools that don't support CycloneDX. If you're already logged into tools that require SPDX and you don't need vulnerability data, SPDX is a decent choice. Third question: do you need vulnerability data? And this is key. If yes, CycloneDX is the only format that includes it natively. Most product security teams I work with end up choosing CycloneDX because vulnerability management is the core job. All right, so when should you use SWID? If you're told you have to use it for regulatory compliance reasons, that's a pretty good use case. I honestly can't think of any other reason to use it, but let me know in the comments if you know of a good use case. Okay, so let me show you what this looks like in practice. So when Log4Shell dropped in December 2021, teams with CycloneDX SBOMs already had a massive advantage. They could query their SBOM files directly for vulnerable Log4j versions, and they could see dependency chains instantly. Teams with SPDX SBOMs had the component list, but they had to manually cross-reference vulnerability databases. And of course, teams that didn't have SBOMs at all had to do it all manually. That difference cost days or even weeks of manual work. When the next major vulnerability drops, you want to be ready using the format that includes security data by default. So let's recap what you now know. SPDX is great for license compliance, but misses security data completely, unless you upgrade to version 3 and use security profiles. CycloneDX was built with security in mind, and it has full vulnerability information. It also includes all of the license info included by SPDX. SWID is used in federal and enterprise contexts, but not widely adopted. So your decision comes down to one major question. Do you need vulnerability data? If yes, use CycloneDX. So here's what to do next. Go generate a CycloneDX SBOM for one of your projects. There's a GitHub action in the marketplace available called CDXGen. Go and set that up and generate an SBOM for yourself. Then you can use a tool like OSV Scanner or Dependency Track to analyze the list of vulnerabilities it finds. That's your proof of concept, so go try it out. Now, I actually go through this in much greater detail in my course. So if you want the full hands-on lab where we build this into a CI/CD pipeline, go check out my course, DevSecOps Pro. In the course, you're going to get GitHub Action templates, an SBOM generation lab, and integration with vulnerability scanners. You'll find a link in the video description below. All right, so if you found this helpful, subscribe so you don't miss the next one. And if you want weekly deep dives like this, sign up for the Product Security Playbook newsletter. It's free. All right, thanks for watching. If you have any questions, please let me know.